And let's take a look at what we'd like to do today is not only get you up to date on what we do, but exactly what we plan to do, what we've achieved in the last year. So some of the things that'll be different. And so as we go through this, we would love to hear any of your feedback and reactions. And so we could put those in the Q&A session or in the chat, and definitely take some notes. And if you can participate in our last mural board session, say that we could. I think that will really be helpful feedback for us. So this talk here is meant to get you updated on what we're doing as a power community. And I just want to emphasize our main goals and our main objectives. How do we do what we do? The first is really an emphasis on taking NASA's research, particularly built around solar radiance products, and supplementing them with information so that you can make actionable decisions. And so that's what we have really endeavored to do. And so that's one of the reasons we want to reach out to you today and present this, because we want to enable these decisions. So whether these decisions are operational decisions, planning decisions for the future, or are research oriented or educational, we'd like to enable those by providing those resources. So first is research to action using NASA data. Second is to build relationships. So you can contact us anytime with our email, and our team will answer you. Of course, so I'm open to emails and discussions. We've also have long-term partnerships that we have endeavored with several different groups. We'll kind of highlight them as we go today, but the point is that we try to engage in users and get feedback along the way, whether informal or formal. That is really critical to enabling action. And lastly, once we learn what your needs are and how and if these data products are suitable for those needs, or if you need additional types of data products, we focus on making all that information accessible to you. So that's accessibility of validated parameters. And we put the word validated in there purposely because we're not just passing along the parameters without understanding that there's uncertainty in these parameters too. So we want to document those and provide those uncertainties for you. We have three areas where we concentrate. So our renewable energy development area, so that's enabling renewable energy technologies, including solar systems, but not just solar. We have some information that's relevant for some wind and numerous other sorts of technologies. Then also, as those technologies are integrated into buildings, we support information needed to evaluate and target and develop technologies for the building energy efficiency and sustainability. And lastly, because of our emphasis on solar radiance, independent from temperature and other meteorological parameters, we try to bring that all together for agroclimatology applications. So this slide just is a acknowledgement that this sort of information is not just required for individual users, but as a corporate bodies, as even the government agencies, thinking of the own U.S. government, we have particular goals and strategic requirements for government facilities to improve energy efficiency, reduce carbon greenhouse gas emissions. And those are even, of course, shared with international as well. And there's many companies, corporations, and others that have their own governments. And goals for this. So, but what's the sorts of information that are needed? Well, these three areas that we support would all contribute to this, and so that's why we focused here. And so we emphasize here the renewable energy still growing at 15% percent per year plus. Expected to do that through 2030 at this, and sustainable infrastructure, building out more energy efficient systems. That's increasing 16-18% per year in terms of modifications to existing buildings and building new buildings, and integrating these technologies. And then agroclimatology is continuing to become more sophisticated and requiring more and more information. And so we support that by we have 4 different purposes here, types of data, and we're under a continual state of improvement, trying to both increase quality and resolution of the products, also incorporate new NASA mission data or new versions of research. So this is something that we do. We also provide these data for at least 30 years now. Actually, some of these data products go all the way back to 40 years. So we can provide long-term information on variability. And then we're looking at adapting and providing, with using some of our same tools, climate change predictions from some of the latest centers, climate prediction centers. So these are all aspects of what we're trying to do. And as I mentioned, this diagram here is meant to kind of give us a circle of how we operate. And so we start down there in the lower left with understanding the user community requirements. And as we do that, we try to understand your needs and the types of resolution, types of temporal resolution that you need, types of parameters or value-added parameters in these various communities that we support. Then we identify the source, and some of those are called out here, whether it's the Ceres project as or the other GPM there is Global Precipitation Mission. So we identify sources of data products that could be used together to make decisions, but we also take those data products and we validate them, or at least evaluate the ones that we can relative to measurements for surface, both in terms of our solar irradiance products, but also meteorological products. So we have an important effort to validate those. And then we have to build out the infrastructure to host and process the data, prepare it so that you can access it. And so we'll show a little bit some of our progress there, but we've processed the data into these cloud optimized formats and make these data application ready in various different specific formats. So we have a number of data formats, for instance, that you can use and access that can immediately be adapted for your purposes or read immediately into your various different tools that you use for analysis. And so the next would be analysis and distribution there. So what are those tools? How do we provide access to the data? How are we making it easy for you to get those data and utilize them? And then as we get down to the bottom right there, education and partnerships, partnering with educational institutions, but also building partnerships and that we've been able to build in the past, and we'll call out some of those in a few slides here. So in terms of the source data, I just want to remind you where these data of solar irradiance are coming from in terms of the historical records, and that is our couple different sources. So we have what we call the Surface Radiation Budget Project, or SRB. So all the irradiance data before 2000 come from that project. This is integrating compositing all the world's geosynchronous plus the NOAA imagers from the early satellites there, and making a 3-hourly data product of radiation fluxes that we release as daily. And we use inputs from the atmosphere and surface, and we use the radiated transfer. That's what RT stands for, radiated transfer algorithms, to estimate those fluxes. But starting about 2000, we have the Ceres project, which is a special instrument made to measure reflected energy from the sun, from the Earth atmosphere system. Also, what we call the thermal infrared emitted energy. And those two together provide an energy balance of the planet. But as part of Ceres, they also estimate the energy that's transmitted to the surface. So if you're talking about sun's light following it all the way through the atmosphere to the surface, what is the estimated energy as a function of time and space? And so they use similar atmospheric inputs, cloud information, aerosol information, information about the surfaces, how they reflect and absorb energy, to make those calculations with their radiated transfer model that they use. And so from 2000 on, well, we use their products, and we provide those products from starting in 2001 on at an hourly resolution and temporal resolution. So that's where those fluxes come from. And then we do have a low latency product from Ceres that provides daily average products that span the gap between when the climate products are released from Ceres and real time to about within 5 days of real time. And then the meteorological products come from another research arm of NASA. That's the Goddard Space Flight Center's Global Modeling and Analysis Office. And they have what they call atmospheric reanalysis. So this is a global model, but it's optimized to global observations. And so there's a number of different types of observations that they process and optimize the model runs to, and then they rerun the forecast once their fields are optimized to get a product that is closer, more harmonious with the observations. And so this is a reanalysis product. And so we utilize those and provide those together with our solar irradiance to provide a complete suite of information for the users. Lately, we've integrated the daily precipitation from the Global Precipitation Mission, and this product's called iMerge, which has a bit higher resolution. The radiation products are about 1 degree, but the GMAO surface meteorology is a higher resolution, about a ½ degree, and then this is a 10-kilometer resolution, or about a tenth of a degree. So, but all this information is available and orderable through our API. So I'll talk about that in a minute. But one thing I did mention is we do validate these data products. So we have networks of surface measurements that are highly calibrated. And so we utilize those to evaluate and provide uncertainty information for the surface solar irradiance that we provide. And also we do the same for the atmospheric reanalysis data products. In this case, it's called MERA2. That is the current version for their long-term data products. And so we do very statistical tests, and we make this information and available on our documentation on our website. And so going to the services that we provide, so some of the things that we do that are perhaps different from a lot of the other sorts of information services. Of course, we feature on the NASA data products from NASA research and NASA research teams, but we have multi-decadal and validated data products for the communities and packaged together, selecting those parameters specifically for individual communities. And then we have numerous other options for access. So I did mention an API. The API is depicted here up there. And over here, an API is just a way to send a URL command and get data. So we have a standard. We've used standardized language here for the API access. We have complete documentation as to how to code up and use those APIs. But this is a kind of a crucial service for us because we've built upon this also what we call our data access viewer. So we'll show some of the latest changes to that data access viewer. But this data access viewer leads you through the selection of parameters according to your community. You can actually now, with this new, visualize them and get a sense of how they vary in time and before you order them. And it actually does give you the URL so that you could use that in the API. So you can use the DAV to learn how to use the API. And then we also have these geospatial services, which we'll describe a little bit later. But the idea here is to support those that use GIS analysis and that they can read these data, they can visualize them, or also read the data in and process them. So I should emphasize as well that we provide global coverage. So we are integrating polar orbiting satellites with geostationary satellites. So that might be as well something different that is that's not covered by some of the other projects. So good to keep in mind compared to. Also, we have these customized data formats and specifically for the communities we support. So how are we doing in terms of metrics? We've processed this. So we had been supporting these communities since about 1999 with essentially ASCII type of data products through this period. And throughout that, we fulfilled about 36 billion requests. But in 2018, we released the new version that was far more supportive and utilized GIS technologies. And you can see we're approaching now 400 million since that time. So over about the 5-year period, we had about a 10x increase in the number of requests we were able to fulfill. So and this diagram here gives the red denotes where the user is located in terms of their server. We don't collect your personal information, but we have an idea where your server was. But we also link to where you requested. So now we can try to track where this gives a sense of the global nature of the data products and that the data products are used by people all over the world and also to obtain information from other parts of the world, whether they reside there or not. So we've fulfilled about 5 million requests over 5 million requests per month, 20,000 unique users. So we're really glad to do these services, and I'm glad that you're interested today to find out more. We did most recently have our most active month ever. And so we're continuing to do that and provide these services. So did I see a hand there? So if you have a question, we can go ahead. You can put some questions in the chat, and our team here is ready to try to answer those as we go. So I just wanted to call out the fact that we do support a whole suite of users from the user community. And one of our longest partnerships is with the Red Screen International team, which is actually a Natural Resources Canada organization that developed a decision support tool. They now have over 800,000 users worldwide, and they enable the sizing and monitoring and sharing of energy, monitoring of energy for buildings and building systems, whether you're connected to the grid or not, all sorts of clean energy technologies they enable. And the DSAT there is a support of the agricultural systems because they use crop models, and that group of crop modelers, they use a specific format which we support. So we support these communities. We've worked with private companies and industrial societies like ASHRAE. We'll show you that in a little bit. And then universities. We've supported universities. So some professors have used power in their classroom, and we're happy to support that. And then, of course, we also have worked with other government agencies, both in a collaborative sense, but also to provide data products and as well. So last year we had a number of lightning talks, and we're looking forward to hearing the lightning talks this year. But last year we learned about a private company called Saildrone flying drones across the ocean. One of the aspects of power is we do have global data products that even cover the oceans. And so there's some use of that we see over the world's oceans. And Saildrone was a company that was utilizing those hourly data products. We've also had other companies using Red Screen to assess their power usage. We've had people develop apps and provide those apps to their users to do design and installation of solar photovoltaic systems. We've had a company doing crop yield forecasts, and this was a crop yield forecast in the Ukraine. So trying to support there. And also we've had another user develop a solar calculator for users doing solar powered water pumping. So just trying again to emphasize that we're trying to provide these data to actually support your actions. So let's, in our last 5 minutes or so, let's take a walk and just look at some of our initiatives and how we've made some progress. So one of the things we continue to do as a team is to enhance the current products and improve them. We also want to improve our hosting environment and looking to improve our spatial and temporal resolution of the products as well. And then we want to enable more analytics and services. So we've made some progress on that. And then we've also want to do some more advanced new types of services like adding global climate model projection information and also integrating new NASA missions, number 8 there. 6 and 7, we hope to do, and we should be addressing 7 somewhat this year with some new NASA measurements, but that's to be determined as we move forward. And probably looking at seasonal forecasts is something for probably next year. So come on back. So one of the things that we want to announce is that we are getting ready to promote our next version, version 10. And so one of the things we had done in version 9 is we had provided climatological values of direct normal radiation along with our solar irradiance and diffuse. So those climatological were adjusted. So those were the old ones. But now this new version, we're featuring the series-based products. But we've noticed that they had a bias of 14% for this. This is the direct normal irradiance. So they had a standard deviation about 50%. We were able to make some adjustments on these parameters to reduce the bias and also the standard deviation. So when we provide these direct and diffuse, we're actually providing now actually to the hourly level. So this is a big change, and this is coming out in version 10 in terms of this new change. We're also made a number of other changes for version 10, reintroducing a half degree. So all the radiation teams are upgrading their data sets to about half degree. So we're already anticipating. So we've replicated radiation to that resolution, and the atmospheric reanalysis data sets are already there. We did introduce some new data parameters, and we're lengthening the time series. We're also improving the way that you can ask for domain and regional data products, and also we're improving the metadata and thus and the metrics to better serve and select different things, different parameters. But bottom line is, if you use the API, you're not going to be seeing any changes other than if we add a new parameter. It'll all be the same language. So what we have is that we have these key source data updates in the next 3 years. So I just wanted to make note that the scientific data sources are improving the data sets. So this SRB, the series, even the flash flux will see significant changes in the next couple years where the resolution is, they are completely reprocessed, improved with a higher resolution. Also, the GMAO is working on new data products that are with improved model physics and also optimization techniques, and also will have resolution improvements. And then as these data products get released, we will be processing and making these available through Power. One of the things that we did make, which change, is we have now serving all our data through a NASA Amazon Web Service cloud system. And so that means all our servers have been migrated and are now operational in the cloud environment. This has allowed us to serve more users simultaneously. And so this has been a big change for us. It's also reduced the downtimes that the old website served locally would experience as they had various different updates to the systems. We have not experienced that because of the way that they can update rather seamlessly. And so that has been a big improvement. We've also done things like optimize data sets for access. So we've quickened up the access, and then we're providing new tools. So another thing that you'll see this year is that we have introduced changes, and we're just about ready to call this released. And this is our new data access viewer. So we've really made a lot of improvements here in terms of the menus, with map-based menus, visualization and charting of these parameters, and the ability to download. We've also hopefully made the data access viewer a little more pleasant to use. But one of the features that we have, besides selecting all the parameters, you can see that over here on the left, different types of parameters you can select, but you can compare them and make some figures of side-to-side figures. You can also use our signal point tool and do some time series or heat maps. So there's a lot of some preliminary analysis that you can do with the new DAV. Another thing that we're working on right now is improving our resolution, and we're going to do that in what we call the TEMPO domain. And TEMPO is a new satellite. It's a geostationary satellite meant to retrieve pollution and gaseous information. And those actually do impact the solar irradiance. And so the long-term goal is to support this at a higher resolution. And so this coming year, we'll be working to do that. And the long-term view would be to incorporate those estimates of those pollutants into the radiative transfer techniques too, so that you actually integrate that into the power fluxes, solar fluxes that you get. And this is hourly, but it's also at a much higher spatial resolution, looking at least 12 kilometers worth of resolution. And so that's one thing that we're doing. We also have just released geospatial services. So a complete set of new geospatial services here in the ArcGIS sorts of formats. So this really supports GIS analysis. And so we have the radiation, which is our solar and thermal infrared fluxes. We have the meteorological quantities like surface temperatures and humidities and winds. We have information on solar geometry. And then we have value-added parameters such as developing the building climate zones that the ASHRAE uses. So we've adapted the ASHRAE, which is the American Society of Heating, Refrigeration, and Engineers, air conditioning engineers. And they have a definition for building climate zones, which are used for your building codes in the United States. And so we have supported and worked with them and implemented ways to visualize their definitions of climate zones. So we can take a look at those and look at the variability. So we have services along those. We also support value-added services for tilted solar irradiance and even battery technologies. One of the new tools that we're developing and we hope to have during this coming year is what we call the Prove tool, the parameter uncertainty viewer. Uncertainties are key to understanding how to use your data products. This tool allows you to get validation instead of just getting ensemble validation or latitudinal validation. We'll get validation for the particular regions for which you need to evaluate and utilize the data. So this is something that is under development. And the last thing I want to highlight today is something that we're working with right now. We're working with NASA's Climate Adaptation Science Investigation Team to support NASA's own centers with providing climate projection data that they can utilize to assess potential building changes in the future. So we've taken some of the latest climate simulations, we've processed them. This is an example of processing the heating degree days, which is a measure of how many days that you require heating. And also, similarly, how many days you require cooling. You can see there's a spread here that depends on the model, whether it has a high, and meaning it has a pathway where there's a lot of continued greenhouse gas emissions, or low. It gives you a nice way to bracket the sorts of projected current projections. So we've done this for all NASA centers, and now this chart shows a comparative way to look at the changes in annual heating and cooling degree days. And so this is the sort of climate services that we hope to introduce. And so we have some of these rolling climate zones and changes in climate zones, and even projected climate zone changes in the future. We'll also provide time series history so that you can utilize tools like the red screen tool I mentioned to assess energy usage in future building. So in closing, just wanted to reiterate, we have a number of ways for you to reach out and learn more about what we're doing. And hopefully our website is definitely one way, but you can see the ArcGIS story maps or the service dashboards or our methodology documentation. You can always email us as well at our project website. So we encourage you to reach out to us. So that is where I'll stop in terms of our power presentation. So thank you for joining us. Please put your questions, if you have any, put those in the chat or in the question and answer. Also, we would love for you to stay and participate in the mural board interactive discussion time at the end of this webinar. So thank you very much.